In the growing industry of renewable energy, success depends on designing systems that are not just sustainable, but also smart, efficient, and future ready. This will be a quick example of how we can use the MathWorks tools to perform all these tasks. So the tools can help you size and optimize your microgrids by using advanced simulation, AI, and model-based design. And this is all before any physical components are deployed. You may ask, why is this powerful? It is powerful because it lets you explore different scenarios, test performance, and integrate renewables such as solar and wind. And all of this is done within a virtual environment. This allows for reduced risks, lower costs, and faster deployment. As you can see, this is an example of the virtual environment in which we have modeled a microgrid. Under each of these systems, there is a subsystem where the actual model is contained. Each subsystem can be modeled with more complexity. So, I will quickly show you that you can accurately model complex subsystems such as battery charging with constant current, constant voltage algorithm. This is a quick look at the in-depth model of the battery. As you can see over here, we have a temperature model as well as an electrical model, and here is the algorithm for the battery. With MathWorks tools, it also allows for us to run a techno-economic analysis to size the renewables in a cost-effective way. So in the back, we have a script, but this is the output of the script. And as you can see, it is sizing the PV, the battery, and the grid with the load power according to the most cost-effective way. Another example of what we can do with MathWorks tools is we can use machine learning to forecast maintenance and extend asset life. The nice thing about all of this is that all the things I mentioned is in one environment. That means your simulation engineering, which is your digital twin, as well as your techno-economic analysis, as well as your machine learning is all within the MATLAB and Simulink environment. This allows for a smarter, data-driven approach to energy system design built on simulation engineering as well as cross-industry delivery.